Alright, so in this lecture I'm going to talk about covalent bonding, which in essence is when atoms share electrons as opposed to atoms transferring electrons from one atom to another, as in ionic compounds. Okay, so the objectives for this particular lecture are for you to determine molecular formulas and structural formulas using Lewis structures for single and multiple bonds. That you should be able to describe polarity. You should be able to determine if a bond is polar or nonpolar. And you should be able to use the equation mu equals QR to calculate dipole moment or charge on each atom in a molecule. So, looking at Lewis structures. So, to review, whenever you want to draw Lewis structures for a molecule, your first step should be to draw Lewis dot diagrams for each element. You should be able to pair up unpaired electrons. And you should add more atoms if necessary, repeating steps 1 and 2 until everybody is satisfied. So for instance, if I were to have the combination of hydrogen and sulfur, hydrogen, Lewis dot structure, has 1 dot. Sulfur has 6. And as we recall, hopefully from the last video, they're distributed in this way. If I were to look at this, our unpaired electrons from other atoms get paired up. So this hydrogen electron gets paired up with, say, this sulfur electron. Now, as you might notice here, this electron is still unpaired. So we have to add another hydrogen atom that can share an electron. So if I were to redraw this, the molecule would look like this. Notice how I can draw a circle around this sulfur now. Oh, and by the way, there should be a hydrogen down here. And it looks as though it has a complete number of valence electrons, 8 valence electrons. The hydrogens are kind of an exception because they only have 2, but that is because they're in the first energy level and there's only a 1s orbital, so they only need to look like helium. In another example, I could give you phosphorus and fluorine. So phosphorus has 5, and fluorine has 7 valence electrons. The quick way to determine valence electrons is again to look at your groups for representative elements. Phosphorus is in group 5A, fluorine is in group 7A. So we see that phosphorus has 1 unpaired electron here, fluorine only has 1 there. So obviously there are still 2 unpaired electrons left on phosphorus, so we need another fluorine to share another valence electron. And we need a third fluorine to share a valence electron. So if we redraw this whole thing, this is going to be notice how this time, instead of dots, for the share, I represented shared electrons with a single line. So one of these single lines equals 2 shared electrons. 1 pair of shared electrons. So if I were to circle things again, notice 2, 4, 6, 8. Phosphorus has its 8. 2, 4, 6, and the 2 shared, 8, 8, and 8. So in this way, elements share electrons in order to get their full valence shells. So just to look at the molecular formula, this is going to be H2S. This is going to be PF3. So H2S, we can either name it dihydrogen sulfide. If it's an acid, this is sulfuric acid. And this is phosphorus trifluoride.